my car back to the dealer. Said this thing is almost new.
This song makes me
I
want to
took
learn
my
how to play the
car back
harmonica.
to the dealer. Said this thing is
Or the banjos.
Enough.
They don't want to know where
No.
who does these.
Yeah, no one will touch that stick wherever again.
It's almost rusted.
All right, so we have the chapter 20, just a little bit out of order. Chapter 20 test hints for you today, and it's a short test. It's like a testlet.
Yeah, or a quiz extravaganza.
Yeah, 17 mind-bending questions about reduction and oxidation, also known as redox,
Redux.
which is actually a test hint.
It is. I'm so glad you mentioned that because I think we just covered test hint number 1.
Yes.
Oxidation reduction reactions happen simultaneously. Remember, you can never have one of these without the other because something's going to happen with the electrons. They're going to go from one place to another, so you got to have them happening together.
Yes.
Let's go on to number 2. The shortened name for oxidation reduction reactions
is
because it's redox.
Redux. They are tied together.
Yeah.
Number 3. In case you're keeping score,
Right.
because we did those first 2 really fast.
Yeah.
Feel free to rewind. Number 3, what happened to electrons in both oxidation and reduction reactions? Well, these 2 processes are tied together.
Yep.
The electrons that are lost during oxidation become the electrons that are gained during reduction.
Okay, we've had 2 mnemonic devices for you. Oil Rig and Leo the Lion says grr.
Grr. Yes.
Oh my gosh, it's been a long day. Oxidation is loss, reduction is gain. Loss of electrons is oxidation, gain of electrons is reduction. And we know you keep getting hung up on that whole gain is reduced thing because its electrons are negative. So you can gain something and be reduced. It's the oxidation number that gets reduced. It becomes lower, more negative
more
on
negative.
the number line.
Right. Number 4, how to identify the specific reducing agent or oxidizing agent in a given reaction.
Now, as you've been working on assignments, we've had you do a couple things where you kind of had to look up those definitions and work through it on your own. Remember, agents make things happen. I gave my kids the example of a Hollywood agent or a sports agent. Like, what does the Hollywood agent or the sports agent do? Well, you know, they book appearances, they get endorsements, they get new work, and maybe, you know, moving to another team, blah, 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 blah. But they're not actually playing the game, and they're not actually starring in the movie. So the agent is making things happen for someone else who's actually going through the process. So the reducing agent is going to make reduction happen for another element, and since reduction is gain of electrons, the only way that reducing agent can make something else gain electrons is if the reducing agent is being oxidized and actually losing the electrons itself.
We'll revisit this concept when we get a little further down and start looking at half reactions.
Right.
So look on that little scroll bar down there on the bottom and note this time. And you might want to come back to this time and we'll actually diagram this when we
Right. So we're going to show you that in context.
Yeah.
But
Okay.
here, this is just basic definition kind of stuff.
Number 5 looks remarkably like number 4 because one question is going to focus on the oxidizing agent and the other question is going to focus on the reducing agent. So you really have to know both.
Right.
Yeah.
Another way you might think about it in terms of the most common examples, reducing agents, again, are things that are oxidized, so that's going to tend to be a metal. And oxidizing agents are things that are reduced, so that's going to tend to be a non-metal, although we know it can happen for 2 nonmetals as well. Number 6
is how to identify the type of reaction when the equation for a half reaction is given.
Okay, so here's an example for you. We have magnesium, the metal, turning into the magnesium ion, which has a +2 charge, because it's got 2 valence electrons, and we electrons being released. Now, something causes this to happen. This is missing a part, which is the ionization energy. So we have to actually put the first and second ionization energy into magnesium to make it do that. And Mr. Suston noted the oxidation state of magnesium over here on the left side of the equation. It's not bonded to anything yet.
It's rule number 4, it's a free element.
Free element, oxidation state of 0. But when it is zapped with that energy and turns into this +2 ion, its oxidation number changes to 2. It becomes more positive. It has lost these 2 electrons. So this is an example of an oxidation reaction. Can we do one that's a reduction?
Sure. Losing electrons is
Oxidation.
oxidation. And some of my students were having a problem with this.
Oh,
This
yeah.
looks like they're added together. But
Right.
you have to realize the way chemists note changes, that this one thing became these 2 separate things.
Right.
So these 2 electrons are now no longer part of this. They are separated and free to go somewhere.
So it's this ion and these 2 electrons.
Right.
So something that would be reduced.
Where might they go? Well, they might go to sulfur. Sulfur could be a free element, and it's a nonmetal,
Non-metal.
and it would be looking to gain a couple of valence electrons.
And it would like to have 2 because sulfur's in column 16. It's 2 electrons away from an octet. So it would love to gobble up those 2 electrons from magnesium.
And how does that happen? Well, it gains 2 electrons.
Okay. So in this reduction equation, we're putting the electrons in, gain of those electrons. Awesome. Let's move on, because we're going to have plenty of time to do more examples like that.
Oh, yeah.
Oh, and so will you.
Number 7,
7.
oxidation number rules.
All of them, they have to know all the rules?
All 6.
All 6
All
rules?
6.
Which are
Do you
really
need
like
to?
4 rules, but they
Yeah.
split out subsets, so.
Yeah, you don't need to know them in like numerical
Yeah, you're
order or
not
anything.
memorizing them, well, you do need to know them, and probably some of you have memorized them, but you need to be able to apply them.
Yeah.
And this is not a question that says, oh, what does oxidation rule number 3 say? This will give you an example, and you have to tell us what the oxidation numbers are. So if we gave you, that's kind of, we're looking at 7. If we
Yeah.
gave you a compound like calcium hydride, CaH2, okay? Calcium hydride. What is the oxidation number of calcium, and what is the oxidation number of hydrogen? So we know calcium from column 2 can only be a +2 oxidation state.
That's it. Column 2 are the alkali metals, aren't they?
No,
They're the alkaline earth
the alkaline
metals?
earth metals.
Yes, that all have 2 valence electrons.
Yes.
Yes.
So that's the only thing that calcium can be. So what's hydrogen? And you might look at your periodic table and say, well, wait a minute, hydrogen's in the first column. Hydrogen's supposed to be +1. Then we've got pluses and pluses, and that's not going to work.
Right, because
Go ahead.
hydrogen is a non-metal.
Right. Technically, it's a nonmetal, and when hydrogen does combine with the metal, it has to act like the nonmetal that it really is and get a negative oxidation number. So here, hydrogen is going to be -1 for its oxidation number, and that balances out to 0 because there are 2 hydrogens. 2 -1 things will cancel.